Hi, we are Group 18. We're introducing the OpenAI Gym. First thing we are going to talk about is what is OpenAI Gym used for. And OpenAI Gym is a toolkit for reinforcement learning research. It includes a growing collection of benchmark problems that expose a common interface in a website where people can share their results and compare the performance of algorithms. Let me briefly introduce the reinforcement learning. The reinforcement learning can be boiled down to five key components. Number one is agent. Number two is environment. Number three, reward and state and action. In our example, the agent Luna performs an action transitioning from one state to another, like walking to sitting. After the transition, the agent receives a reward, like treats. These agent environments cycle across all reinforcement texts. Now, while the reward usually has a positive connection, in reinforcement learning, we have negative rewards as well. Then let's talk about some background. OpenAI Gym was first introduced in April 2016. Since then, it has seen continuous development, with new environments being added and existing ones being improved over time. OpenAI Gym environments were not collected in traditional sense like data or artifacts. Instead, they are custom designed by researchers and developers who are interested in creating specific text or simulations for the reinforcement learning experiments. These individuals use their expertise to design the rules, dynamics, and rewards of each environment. OpenAI Gym environments are implemented using Python and are typically built on top of simulation engines or libraries. Developers create these environments by specifying the rules, dynamics, and rewards of the text they want to model. The environments are designed to provide a clear and standardized interface, making it easy for users to interact with the experiments with reinforcement learning algorithms. OpenAI Gym has an open source and community-driven development model. This means that developers from around the world can contribute their own custom environments, improvements, or extensions to the platform, leading to a diverse and ever-expanding set of environments. Now we're going to discuss some advantages of OpenAI Gym. First, it has a unified interface. One of the central features of OpenAI Gym is its unified interface. All environments adhere to a consistent API, making it easy to switch between different tasks without significant code changes. This standardized interface simplifies the development and evolution of reinforcement learning algorithms. Secondly, benchmarking. OpenERGM provides a platform for comparing the performance of different RL algorithms on common tasks. This helps researchers assess the effectiveness of their algorithms and fosters healthy competition and collaboration in the RL community. Thirdly, extensibility. Users can create custom environments and integrate them into OpenAI, expanding the available tasks and challenges. This encourages community contribution and diversity. Last, it has it has included many types of environment, such as algorithmic, Atari, Box2D, Classic Control, Mujuku, robotics, and toy tasks. It
each representing a specific task or problem, such as games, robot control, and physics simulation. Then we're gonna talk about the structure of OpenAI. The structure of OpenAI Gym consists of several key components and concepts that work together to provide a flexible and standardized framework for developing and testing reinforcement learning, which is RL algorithm. Here is an overview of the main components and their structure. The first component is environment. OpenAI Gym offers a wide variety of predefined environments. Each represent a specific task or problem. These environments are organized into categories like algorithmic, theory, credit control, and more. Environments are implemented as Python classes, and they provide method for interacting with the environment, such as reset, which is to start a new episode, step, which is action, to take an action in the environment, and render, which is to visualize the environment. And next structure is space. Gym environments use the concept of spaces to define the possible states and actions within an environment. There are two main types of spaces: observation space, which is state space, and action space. Observation spaces and action spaces can be discrete. For example, a finite set of discrete value or continuous, like a range of real numbers. These spaces define the valid inputs and outputs for an RL agent. Third, there is an agent in this structure. RL algorithms are implemented as agents that interact with the environment by selecting actions based on an observation and previous experiences. Agents typically use policy functions or queue functions to make decisions and update their strategies based on reward received from the environment. And the structure in RL or in OpenAI Gym is training loop. RL training involves repeatedly interacting with an environment, collecting experiences like observations, actions, rewards, and updating the agent parameters to improve its performance. The common RL training algorithms like Q-learning, deep Q network, which is DQ, also known as DQN, and policy gradient methods are used in the training loop.
This challenge, we want to represent a classic control problem. We use Carpool version 1 in an AI gym. In this environment, we want to control an inverted pendulum system to keep it balanced. The main component of this environment is a horizontal cart that can move along a track and a long pole attached to the cart. It is capable of rotating around the horizontal axis. The goal is to apply left or rightward forces to keep the pole upright. If the pole tilts beyond a certain angle in either direction, or if the cart moves beyond a certain range, the environment is considered terminated and the program ends. For the code, we first can create a cart pole environment. Then we need to reset the environment to get the initial stage. We can define the number of frames to visualize, then render the current frame. We then perform a random action, and finally, we can execute the action in the environment. Please make sure you have the necessary dependencies, such as AI Gym and Matplotlib.